What do you know about absolute value? What have you learned about absolute value? Precious, start us off. Absolute values turn negative numbers into positive numbers. Give me a thumbs up if you agree with Precious. Good. What else have we learned about absolute value? Yes.
It's like how far away it is on the number line.
Good. From what?
0.
That's right. Absolute value is the measure of how far something away, or how far away something is from 0. You guys good? Yeah?
Sorry.
Okay.
Sorry.
It's how far something is away from 0 on the number line, right? So let's look at this number line up here. And if I took the number 8, how far away from 0 is the number 8? How many spaces away is it? It's 8 spaces away. How many spaces away from 0 is negative 8? 8 spaces. I wouldn't say it's negative 8 spaces away, right? Because it is physically 8 spaces away. So when we initially learn absolute value, your teachers tell you, oh, these little things just make everything positive. That's not necessarily what it is we're doing. Distance cannot be negative, right? If I'm going 2 miles this way, if I went this way, would it be going negative 2 miles? No, I can't go a negative distance because distance has a length and it has a direction. North, south, east, west, however many miles. So negative 8 is just as far away from 0 as positive 8. That's why when we do absolute value, those numbers are actually the same, negative 8 and 8, because they're the same distance away from 0. Thank you, Ben, for adding that. That's great. So let's look at an example. If I have the absolute value of n minus 3 equal to 5. N minus 3 is an expression. Okay, we might as well call it x, but it's n minus 3. Bless you. So again, because of the way that we've been taught absolute value, a lot of you, well, not a lot of you, some of you are tempted to look at this and go, ooh, I'm going to turn that minus 3 into a plus 3. Okay? We do not want to do that. Okay? N minus 3 is its own entity. I cannot change anything about it. So I have to keep it as n minus 3. Now, this, expression here, the absolute value of n minus 3, represents a distance, okay? And in this case, it's equal to 5. So because 5 is positive, I've got half of my equation set up already. But I want to split this into 2 scenarios, one with a positive solution and one with a negative solution. So on the right, I have the absolute value of n minus 3 equals 5. On the left, I've got the absolute value of n minus 3 equals negative 5. 2 different scenarios. And it looks like one long equation, but really this is just for us to save time and make our work look a little bit neater. What do I normally do with an equal sign when I'm about to solve an equation again? I draw my line down it. But this time I have 2 equal signs that I'm going to draw my lines down. Now, when we do this, we're going to pretend the absolute value signs are not there. We've split this into 2 separate scenarios, a positive solution and a negative. So we're going to pretend these little guys are gone. Okay, you could rewrite it without them, but I'm not going to do that. Now, n minus 3. What would I normally do to cancel out that minus 3 on both sides? I do plus 3. So now I'm not just going to do plus 3 over here and plus 3 over there. I'm also going to do it over here. All right. What happens to my pair of 3s in the middle?
0.
0, cross them out. Leaving me with n is equal to, well, what's 5 plus 3? 8. What's negative 5 plus 3? Negative 2. So what I come up with is negative 2 is equal to n, which is equal to 8. How many solutions does this equation have? 2. That's right. So we talked about one, many, or none. This has 2. Negative 2 and positive 8. Well, what does it mean for this equation to have 2 solutions? Negative 2 and positive 8. Well, let's plug those numbers in. Is that how you spell plug? No. That says plug. Plug in. Okay, if I have the absolute value of n minus 3 equals 5, and the absolute value of n minus 3 equals 5 again, because I have 2 solutions, I'm going to plug and check twice. The first number I'm going to plug in is negative 2. The other number I'm going to plug in is positive 8. Everybody with me so far? Yeah? Okay. What is negative 2 minus 3? Negative 2 minus 3, you guys don't know that? Negative 2 minus 3? What is it? Negative 5. If I spend $2, then spend $3 more, I've spent $5. What about 8 minus 3? What would that give me? Over here. That's positive 5. You guys all see that precious question? Okay. So when I see the absolute value of a negative number, what does your brain want to do? Change it into a positive. The absolute value of negative 5 is equal to positive 5. Is positive 5 equal to positive 5?
Yes.
Yes, it is. What's the absolute value of positive 5? Also positive 5. Is positive 5 equal to positive 5?
Yes.
Yes. So here I have 2 solutions. They both work out. Now again, yeah, Precious. If you've done everything right in this part, you don't technically have to go through and check them. If you check them and one of them is off, then something went wrong up here mathematically. But they should always both work out. Now again, we're taught in elementary school. I remember in elementary, like 5th, 6th grade, being taught absolute value. Oh, it just makes everything positive. That's technically not true. Now it looks like, yeah, I have a negative 5 in the absolute value. They disappear along with the negative, leaving me with a positive 5, right? But really, this absolute value is asking the question, how far away from 0 is this thing in the middle? I'm going to say that again. The absolute value symbol is asking you, how many spaces away from 0 is this number in the middle? So let's go to negative 5. Here's negative 5. How many spaces from 0 is negative 5? It's 5 spaces away. So the answer to how many spaces from 0 is negative 5 is 5 spaces. In the same way that how many spaces away from 0 is positive 5? 5 spaces. That's why they're both equal to 5. Because distance can't be negative. It's the same going left or going right. Quick show of thumbs. Is that making sense? Am I being confusing? Don't be scared to say yes. I can take it. Okay. I see a lot of blank stares, which either means that we or exhausted or confused. Either way. Now, there's another way we could do this if this is confusing, and this is confusing for some people. Here's a different way to do it. You guys ready? Let's say I have the absolute value of 4x minus 8 being equal to 20. Now, this method here, some of you may be like, oh, that's super easy. That's very straightforward. I get how to do that. I'm going to do that. Perfect. Do that. Some of us look at this and go, I have no idea what's going on there. So this is a way, it's just an alternative way. It doesn't necessarily mean it's easier or harder. It's just an alternative way. I could split this up into two completely separate equations. 4x minus 8 equals positive 20. And 4x minus 8 equals negative 20. It's the exact same thing as what we did in the previous problem, except instead of having one big joint equation, it's two separate equations, which for some people helps us understand it a little bit better. It is slightly more work, but it's the same thing. I'm going to split my equal signs. What's the first thing I want to do if I want to get x all by itself in equation 1? Are we going to divide by 4? We're going to... That's right. We're going to add 8 to both sides. Add 8. Add 8. Bless you. And I'm going to do the same thing over there. Actually, let's just focus on one at a time. After I add 8, my 8's go away. I'm left with 4x equals 28. What can I do now? Divide both sides by 4. How many times does 4 go into 28? So I get x is equal to 7. There's one of my solutions, but I need 2 of them. Again, over here, I added 8. Those go away. I'm left with 4x equals negative 12. Again, divide both sides by 4. What's negative 12 divided by 4? Negative 3. There are my two answers. X equals 7 and x equals negative 3. Is that making sense at all? A little bit? All right. Let's jump right into the practice. I'm sure it won't be too